In the last presentation we completed 4x1 mux. Now in this presentation we will complete 8x1 multiplexer. So the first thing that we have to see is the number of data input line, and it is 8 in this case. You can also see here 8 data input lines from I0 to I7. So I can write n is equal to 8, where n is the number of data input line that we have already saw, and 8 can again be written as 2 having power 3. Okay, now you already know m is the select line or the selector variable, and it is equal to log having base 2 n. Okay, I will replace this n by 2 having power 3, so m is equal to log having base 2 then 2 to the power 3, and it is equal to 3. Okay, so the number of select line in 8x1 multiplexer is 3. So let's draw 3 select line. Okay, this is your S0, this is your S1, this is your S2. Okay, now the next step in 8x1 multiplexer is to form the table. I have already drawn the table, so let me paste it down. Okay, there are S2, S1 and S0, 3 select line, and as there are 3 select lines, we are having 8 possible combinations. The next important thing is to determine the value of the output, or how it multiplexes depending upon S1, S2 and S0. So when all these 3 S2, S1 and S0 are 0, y is equal to I0. Okay, I0 will be routed to the output in this case. Similarly, when S2 and S1 are 0 and S0 is S1, I1 is routed to the output. So I will complete this table now. I0, I1, I2, I3, I4, I5, I6 and then I7. This I7 input will be routed to the output y when all these 3 are high. Okay, now we have to see for the expression y is equal to, let's see for the first case, I am having S2 complement, S1 complement, S0 complement, I0. Similarly for the second case it is S2 complement, S1 complement, S0, I2. For the third case S2 complement, S1, S0 complement, this is I1, sorry, and this is I2. And for the fourth, S2 complement, S1, S0, I3. And let's complete the rest. S2, S1 complement, S0 complement, I4. S2, S1 complement, S0, I5, S2, S1, S0 complement, I6, and in the last case S2, S1, S0, I7. Okay, you can see that I have not taken enable into the account like we did in the 4x1 multiplexer, but at the end when we are done with the implementation of this logic, I will tell you how to implement this thing by using the enable. So this is the circuit that we draw depending upon this expression, and E0, E1, E2 are same as your I0, I1, I7, and A, B, C are same as your S2, S1, S0. I just took this different name because in some textbook they represent the data input by E0, sometime D0, and the select variables by A, B, C, and this is your Y. Okay, and if you want enable, then you have to add AND gate here and then enable at this point, and instead of having Y at this point we will have Y as the output of this AND gate, and you will add enable here. Okay, where E is your enable. So this is all that we have to do in the 8x1 multiplexer. All these min terms, this one, we are having total 8 min terms, and all these min terms are implemented by using this different AND gates, 8 AND gates here, and the output of this AND gate is going to the OR gate. Okay, so this is very simple thing, very similar to your 4x1 multiplexer. The only difference is the number of select lines and the input. Rest of the things are same. The approach is very much same. Now we are done with this basic. The next thing that we have to do is the mux tree, which is the implementation of the one type of mux by using the other type of mux, which is very important topic. So in the next presentation we will move to the mux tree. So see you in the next one.